Hi, and welcome to the Intrepid Sea, Air, and Space Museum's live virtual programming. My name's Kara, and I'm an educator here at the Intrepid Museum, located in New York City, and I will be leading you on today's program. Now, just as a reminder, the museum's live streams are free, but if you'd like to help us in delivering this content, please click on the link located in the chat or the comments, depending on what platform you're using. Now, speaking of the chat, feel free to let us know where you're tuning in from. Have you ever been to the Intrepid? As well as participate and ask questions throughout today's program, too. Again, my name is Kara, and I'm an educator at the Intrepid Sea, Air, and Space Museum, where our mission is to honor our heroes, educate the public, and inspire the youth. So let's get started. Today, we're going to be talking a little bit about what it takes to get these space shuttles and capsules up into outer space and the type of rockets that get them up there, right? So just to get us started with a little bit of background information, this is the Intrepid Museum. It's located on the west side of Manhattan in New York City, right in between New Jersey and New York, right on the Hudson River. What's really cool about the Intrepid Museum is that it's actually housed inside of a historic World War II aircraft carrier, the USS Intrepid. Now, just a couple of quick facts. The Intrepid is so long, you could play about 3 games of football on the top at the same time. It's about 913 feet long. If you're walking down that West Side Highway, you can't miss us. It is huge. Okay? If you were to measure from that top point to the really bottom there, it'd be about 8 stories tall. Now, Intrepid began construction in 1941, right before the U.S. was sent into World War II after the bombing of Pearl Harbor, and was finished in 1943. The Intrepid participated during World War II, the Vietnam, and the Cold War, and also did some work for NASA, which we'll talk about in just a little bit. Now, what would you call a ship that carries aircraft? Let me know in the chat if you know what type of vessel carries aircraft, right? Now, during World War II, it was really difficult to get these airplanes from one continent to another, so they had a little bit of help. Now, not only did Intrepid carry airplanes, but they were also able to launch and land. So if you were thinking aircraft carrier, you'd be on the right track. Like I said, not only did Intrepid carry these airplanes, but they were also able to launch and land just like a floating airport. Now, Intrepid was in service from 1943 to 1974 before becoming the Intrepid Sea, Air, and Space Museum in 1982. So it's kind of a given why we're a sea museum. You can see that we are a large ship that sailed out in the ocean, right? Now, we're an air museum because not only did we carry aircraft, but they were able to launch and land. And today at our museum, we have about 24 aircraft in our collection. Everything from aircraft that flew during World War II, like our Avenger, to jets that came out during the Vietnam War. Right? Also, not only do we have these 2 types of planes, but we have planes like the A-12 and the Concorde, right? But you're probably wondering, why are you a space museum? Well, this is why we're a space museum. Let me know in the chat if you can tell me what this is. If you look really closely on top, it says United States on it. It even has the U.S. flag on there as well. Let me know in the chat if you know what this is, or maybe how it relates to us being a space museum. Think about what this object could be. So I see a lot of us are saying a space capsule, right? And this space capsule would sit on top of a rocket, right? Either an Atlas or a Redstone rocket. This would launch up into space, and this capsule would separate, and sometimes it would just go up and down, or it would orbit around the Earth as well. So during the 1960s, or 50s, there was something going on called the space race, right? It was between the United States and the Soviet Union. And at the time, they were called, not today they're Russia, but at the time they were called the Soviet Union. And the space race officially started when the Soviet Union launched Sputnik on October 4th of 1957. This was the world's first artificial satellite and the first man-made thing to actually orbit around the Earth. Now, like I said, we were participating in a space race. So let me know in the chat if you know where a good place to land, or maybe what a good finish line for the space race would be in outer space? Let me know in the chat. Maybe a place that we could land on that's somewhat close to Earth, right? What is the point of a space race? So if you were thinking the moon, you would be correct. Our finish line was to get to the moon, right? But in the 1950s and 60s, this was the beginning of getting and sending humans to outer space. So you couldn't just put astronauts in a space capsule, send them to the moon, say good luck and hope you get there, right? You have to take these baby steps to make sure that everything went well before eventually getting to the moon. First, how do you get up there? What do you need to take with you, right? These baby steps to eventually get us up there. Now, NASA decided that they were going to get to the moon in 3 parts with Project Mercury, Project Gemini, and the Apollo missions. And so talking about the Mercury missions, these are the Mercury 7, or the astronauts that would participate during Project Mercury and those early space explorations, just getting up there, the beginnings, right? We're going to be talking a little bit about Scott Carpenter, and right there highlighted is Scott Carpenter, and this is his Aurora 7 capsule, right? This capsule, like I said, would sit on top of an Atlas rocket. He would launch up into outer space. He'd orbit the Earth 3 times. He was only up there for roughly about 5 hours, about 4 hours and 39 minutes before coming back down to outer space. Now, that rocket that he would ride up on was about 95 feet long. So in comparison to some of the rockets that we're going to take a look at, wasn't very tall, right? So like I said, he orbited the Earth 3 times before coming back down to Earth. And let me know in the chat if you know of a good place that he could possibly land. Maybe the Earth is covered in a large amount of it, maybe 71%. Let me know in the chat where a good place to land might be. So he would, of course, let out his parachute, right? That would kind of slow him down, help him glide back down to Earth, where he'd land in the ocean, right? And can anybody tell me of maybe a large vessel nearby that could maybe deploy a helicopter to go pick up Scott Carpenter when he had come back from outer space? Let me know in the chat if you know anywhere he could have possibly have gone to after being picked up from this helicopter. A place that's very near and dear to my heart. I see some of us are saying the Intrepid. That is correct. The USS Intrepid was actually responsible for picking up Scott Carpenter, right? Really a particular story that we like to tell, or interesting story, right? As Scott Carpenter was coming back down from outer space, he got a little bit distracted looking out his window. And if I'm being honest, I think that if I were coming back from outer space for the first time, I'd get a little distracted. And so he says that he got a little distracted and he accidentally pushed a button 2 seconds too late that would activate his retro rockets, actually landing him about 250 miles off course. So thank goodness it took him a couple hours. I believe it was 3 hours to find him, right? But the Intrepid finally found him and was able to bring him on board. But Scott Carpenter wasn't the only astronaut that Intrepid picked up. And we'll get to that in just a second. So I'm going to pause here and see if anybody has any questions. Does anybody have any questions? Why was the capsule named Aurora? So I did mention that his capsule was the Aurora 7, right? And Scott Carpenter named it like that because he wanted it to represent the open sky and the age of a new dawn, symbolize the dawn of a new age, right? Like I said, this is one of the first times that we're actually getting up into outer space, leaving Earth for the first time. So it was a really big deal for them to name their capsules too. I've also heard that Scott Carpenter also lived on Aurora, I believe Lane, when he lived in Colorado as well. So it's a really interesting connection too. Any other questions? How heavy was the Atlas rocket? Right, so his Aurora capsule sat on top of this rocket. And the rocket was about 94 feet tall. It's about 10 feet in diameter and weighed about 260,000 pounds. Its payload capacity was about 3,000 pounds. That included the astronaut and his space capsule. So it sounds like these really big numbers, but as we go on through the program, this is really small compared to some of these big rockets that we're going to be looking at. Awesome questions. So like I said, the Intrepid did not only pick up Scott Carpenter, but they actually picked up these two astronauts as well. After the Mercury project came Project Gemini, and this was the first time that we were sending two astronauts into outer space. We were taking things a little bit further, right, by actually going further, staying up in space a little bit longer, testing out more food, kind of seeing what it was like to be up there a little bit longer. During the Gemini 7 mission, astronauts were able to stay up for about 2 weeks, about 14 days, side by side for 2 weeks in outer space. I don't know if I could do something like that. But the Gemini 3 mission took up these two astronauts here, Gus Grissom and John Young. They sat on top of a Titan II rocket. It was about 109 feet tall and weighed about 340,000 pounds. Its payload capacity was a little bit more than the Atlas rocket at about 8,000 pounds. Remember, we're taking up a little bit more mass and we're going a little bit further, doing things a little bit differently, right? Now, fun and interesting story about Gus Grissom and John Young was back in 1965, space food was really awful and really gross. It was dehydrated, it was freeze-dried, and it was bite-sized and coated in a gelatin or an oil to prevent it from crumbling in outer space, right? Water would be reintroduced into it and they'd have to kind of squish it around and slurp it up. Not the most appetizing meal, but they were experimenting with space food, right? This is, again, the early times of space exploration. Now, during their launch, John Young actually pulls out a corned beef sandwich on rye that he had snuck into outer space, and he actually begins to eat it, right, with Gus Grissom there. Now, let me know in the chat why you think this might be extremely dangerous. Why would it be so dangerous to smuggle up a sandwich and take a bite of it in outer space? Why do you think NASA said, no, this is not allowed? Let me know in the chat. Why do you think that it would be really dangerous to take up what seems like a harmless sandwich, right? Well, we know that in outer space, we have something called microgravity, right? Really, really little amounts of gravity. If you take a bite of that sandwich here on Earth, those crumbs are going to fall down to your lap. But if you're in outer space, those crumbs are actually going to start floating. They can get into the astronauts' eyes. They can get into their ears. They can actually get lodged in buttons and get into the ventilation system. It's a lot of issues and a lot of problems that could come from just eating a sandwich, right? They're on very expensive technology that is supposed to bring them back home safely. So, of course, when they returned back down to Earth, they got in a little bit of trouble. They had to personally apologize to Congress for possibly putting this mission in jeopardy. And NASA warned future crews that nobody better ever pull this stunt again. But this is actually the reason that NASA knows you can't take bread into outer space because it crumbs. Today on the International Space Station, they have tortillas that they make peanut butter and jelly or sandwiches when they are really craving a sandwich. So Gus Grissom and John Young were also in space for, they orbited the Earth about 3 times. They were only up there a couple of hours. So again, doing very simple experiment, just going up, orbiting 3 times before coming back down to Earth. When they came back down, it looked a little like this. Again, they're going to put out their parachutes, going to slow them down, create a little drag. They're also going to land in the ocean, right? And can anybody tell me of a large vessel that might also be nearby that could possibly pick up these 2 astronauts that are out in the middle of the ocean? Let me know in the chat if you know what big, beautiful aircraft carrier that could be out to pick up these astronauts. So while Gus Grissom and John Young are waiting to be picked up, you can see here on this picture to my right that there's this kind of like a floaty device, also called a flotation collar, around their capsule there. You can see that there is this green liquid coming out of it as well, and that's so that whoever's coming to pick them up can find them a little bit easier, right, if you've got that green liquid out there. And that flotation collar keeps that capsule from sinking. And that is because Gus Grissom, who had also been a Mercury astronaut, had come back down to Earth in his capsule, had landed in the ocean just like Scott Carpenter, but the hatch to his capsule popped off. Now, If that capsule hatch pops off, water's surrounding him. It's actually going to start filling his capsule with water, and his capsule actually sunk to the bottom of the ocean and didn't get retrieved for like 30 years. Luckily, Gus Grissom was saved, and of course he went up into on the Gemini capsule as well. But that's one of the reasons that there's a flotation collar. It's also the reason that he named his capsule Molly Brown, after the Broadway musical The Unsinkable Molly Brown. Right? So you might have guessed that the Intrepid was that big, beautiful vessel that came and picked up these astronauts and their capsule. If you come to the Intrepid today, you can actually see a replica of what that would look like as the Intrepid is picking up that capsule to bring it on board. So I think now is a good time to stop and take a question break. How many Gemini astronauts were there? So there were 10 crewed Gemini missions with 2 astronauts on each. There were 16 astronauts and 4 flew twice. Good question. What were some improvements between the Atlas rocket and the Titan II rocket? Awesome. So really good question. Aside from being taller and heavier, the Titan rocket also promised more reliability than the Atlas rocket because its fuel type had fewer components, which are still being used today. And we'll talk about that in just a little bit. There was also a system installed to let the crew know if anything was going wrong with their rockets, as well to improve response time to any emergencies that might have occurred, right? The reliability of the Atlas rocket was really scary. And back in 1959, after the Mercury astronauts had been selected, NASA took them to the launch site so they could watch these, Atlas rockets that were going to take them up into outer space. And a minute after an unmanned Atlas rocket took off, it exploded. And these astronauts kind of looked at each other like, we have to ride on that to outer space? So later on, the Titan rockets actually became a lot more reliable, right? These rockets in the beginning were actually used as weapons, so they had to kind of make them a lot safer to carry astronauts into space. Good questions. So I did mention that NASA broke up going to the moon in 3 parts: our Mercury missions, our Gemini missions, and our Apollo missions, right? And again, everything that we were learning from Mercury and Gemini helped us to eventually land on the moon, which we did on July 20th of 1969. Can anybody in the chat tell me this famous Apollo crew that landed on the moon? 2 walked on the moon and 1 drove, basically the getaway car that orbited around waiting to pick up those other 2 astronauts. Now, there were 6 Apollo missions that successfully landed on the moon with our famous Apollo 11 crew here. Neil Armstrong. Yeah, and I see Chris in the chat saying the Apollo 11 crew, right? We have Neil Armstrong, Buzz Aldrin, and Michael Collins, who drove, like I said, basically that getaway car waiting to pick up his fellow astronauts to bring them home safely. Right? There were 6 missions that were able to do this. And they brought back about 400 kilograms of lunar samples. They did all kinds of research on the moon and experiments on things like meteoroids and solar wind experiments and so much more. Now, the Apollo missions rode up on the Saturn V rocket, which you can see on the right-hand side there. It is the tallest, the heaviest, and the most powerful rocket that's ever been brought to operational status. To kind of compare it to the other rockets that we've been looking at here, you can see that it's almost 3 times as tall as just the Atlas rocket. It's also so much heavier. Again, we're not just going up and down or up and orbiting, but we're actually going on a 3-day journey to and from the moon. So it's got to have a lot more power. It's also a lot heavier. The more fuel you add to it, the heavier it's going to get, the harder it's going to be able to launch, the more fuel you're going to need. You can kind of see that vicious circle here, right? So it's a lot heavier and it's a lot taller, right? So after the Apollo missions, NASA wanted to focus on low Earth orbit, right? They weren't going to the moon anymore, but they wanted to focus on low Earth orbit and basically hanging out around the Earth, taking things up like satellites, parts of the International Space Station, and they were able to do it with vehicles like this. This here is the Space Shuttle Enterprise, and you can find this at the Intrepid Museum on its flight deck all the way towards the end there. And I hope I don't ruin your day by telling you this, but the Enterprise Space Shuttle never went into outer space. The highest it ever went was about 26,000 feet. So if you've ever been on an airplane before, you've probably gone higher than Enterprise. And it only went about 470 miles per hour. Went on the back of this 747 jet called a Shuttle aircraft carrier during its approach and landing tests, or its ALT. Now, you're probably wondering, why? Well, Enterprise was the first shuttle ever built. It was a prototype. NASA needed to make sure that this shuttle could actually get up into the air and glide back down and land on a runway just like an airplane could before they even thought about sending shuttles into outer space. So you're probably wondering, well, how did we get from Space Shuttle Enterprise that only went about 26,000 feet to shuttles like this one right here that went about 350 miles off the surface of the Earth and went at top speeds of about 17,500 miles per hour? Enterprise rode on the back of a 747 jet, but how did we get these space shuttles up into outer space? Well, it takes a little bit of physics and a whole lot of rocket fuel. So let's talk about those physics, right? Some of us have probably heard of Sir Isaac Newton, right? He's the grandfather of modern day physics. Most people know him as the destroyer of GPAs, right? But we might have heard of Newton's 3 laws of motion, right? And we're going to talk about how those relate to launching space shuttles from Earth. So let's talk about Newton's first law, inertia, right? So basically, inertia says an object in motion will remain in motion until acted upon by an outside force, or an object at rest will remain at rest until acted upon by an outside force. So if you think about our shuttles getting up into space, right, there's no air resistant that's going to be holding that shuttle back. So that shuttle is just going to keep going until acted upon by an outside force. But if you think about that shuttle sitting on the launch pad here on Earth too, it's not going to go anywhere until it's acted upon by an outside force to actually get it up off the ground and into space, right? Newton's second law is force is equal to mass times acceleration. Basically put, we need to move, acceleration, stuff, our mass, right? If we think about in the case of our shuttle, right, that stuff is rocket fuel, and to get it moving, we're going to ignite it. Looking at Newton's third law, for every action, there is an equal but opposite reaction. Basically, if you've got a force in one direction, you're going to have a force in the opposite direction that is equal as well. Now, it's important to remember that when these shuttles are actually launching off their launch pad, that downward flow of exhaust out of the rocket does not propel it, but it's the force that's actually pushing on the top of the rocket that's getting them up into space. So we've looked at Newton's laws, right? So we're going to need a little bit of physics and a lot of rocket fuel. So I want us to take a look at a shuttle stack here, right? And that is the Space Shuttle Orbiter, that's the solid rocket boosters, and that external fuel tank, which is that orange part right there, right? The shuttle and the whole stack is not, or the shuttle's not only taking itself up, but everything is going up as one mass. We're one shuttle stack, right? So I want us to take a look at this picture. And if you look down there at the bottom, you can see those buses. There's some trucks. They're really little compared to this massive shuttle stack that you have here. I'm going to break it down, and we're going to talk a little bit about the mass of each one of these components. If you look at the shuttle, space shuttle itself, it comes in at about 150,000 pounds. Now that's empty. There's no astronauts in there. There's no payload. There's no equipment, just the shuttle, 150,000 pounds. If you look at those SRBs, or those solid rocket boosters, those are those two white parts that are on the side there. Each one of those weighs in at about 1.3 million pounds filled with fuel. If you want to in the chat, you can also add these up at home and tell me how much you get at the very end. It's going to be a really large number. If we measure, or if we weigh the liquid fuel tank, or the external fuel tank, or that big orange hot dog, as I like to call it, comes in at about 1.6 million pounds filled with fuel. And like I said, we haven't even added in our supplies yet, our astronauts, our equipment, all of the stuff that we're taking up into outer space, their payload weighs in at about 12,000 pounds. Let me know in the chat if you happen to have added all of this weight together. Tell me what you get. It should be about 4.4 million pounds. That is riding basically an explosion all the way up into outer space. Now, the further you want to go, or the more you're going to be taking up, it's going to require more fuel, right? We talked a little bit about that earlier. The more you want to take up, the more fuel you're going to need. The more fuel you add, adds more mass. More mass means more fuel. Again, this vicious cycle of what we're going to be taking up. Right? But with the right balance and manipulation, we can really get these heavy machines up into orbit. So let's take a look at these rockets here, and I'll make it a little bit bigger for us there. Looking back from our beginning rockets to the STS, you can see that it didn't really get taller, but it got a lot heavier, right? We're taking up a lot more. And we're not going very far, or they're not going very far, but they are just orbiting around the Earth. But it takes a lot of fuel to get that entire shuttle into space. So it's very easy to get caught up in the lights and the camera and the action, right? But we're going to take a look at what's actually going on inside of these rockets that get them up into space. So let's take a look at the reaction that it takes to get these up. So if we think about it like a candle, right? The candle is, we're going to be having fuel, right? And the fuel is that stuff that burns. If you think of it like a candle, the fuel is like the wax or the wick of the candle, right? In a rocket, it's going to be our propellant. Now, we can't have a flame without oxygen. Add that in there. There we go. And when ignited, our oxygen is going to bond with the fuel, which is then going to release heat. Now, ignition is the heat that you need to get things started. And by putting energy in, you begin this process, and you should get fire, right? So right before our space shuttles launch here, you can see that there were sparks coming out. Now, that is used to burn off any excess vapors that might be coming out of this air, or might be lingering around this area, right? Also, before the space shuttle launches, there's a big pool of water that surrounds the shuttle stack, and that's the sound suppression system. It's used to absorb any acoustic energy. The sound coming off of these rockets can reach about 200 decibels and can be reflected off the ground and off the platform and bounce back onto the shuttle, and could compromise the shuttle and the crew inside as well. By putting that pool around, the sound is dissipated by huge volumes of water across the platform. So as we look here at our space shuttle's main engines, you can see that blue flame coming out, right? Now, those blue flames are coming out of the space shuttle's main engines, and that's created by burning liquid hydrogen and liquid oxygen out of the main fuel tank. Now, if we've taken a very basic chemistry class, right, we know that liquid oxygen and hydrogen make water. So coming out of the space shuttle's main engines is about 3,000 pounds of water per second when burned. The liquid hydrogen can generate about 375,000 pounds of thrust at liftoff. Looking at our SRBs, or our solid rocket boosters, each one of those can produce about 2.7 million pounds of thrust each. Now, inside of those solid rocket boosters, you have a solid fuel that's made of powdered aluminum and ammonium perchlorate. If you were to touch it, it'd kind of be like the consistency of a pencil eraser. You don't want to be near these chemicals. They're pretty nasty, right? So after launch, you can see here, this is about 2 minutes after launch, and something really interesting is going to happen. Our solid rocket booster is going to fall and head back down towards Earth. Let me know in the chat why you think our shuttle stack might let go of our solid rocket boosters and send them back to Earth. They're going to land in the ocean, and NASA's going to pick those up, and they can actually be used after they're recovered. They could be used again for future missions. So again, let me know in the chat, why would we send our solid rocket boosters back down to Earth? At this point, we're about 24 miles high. They get us about 24 miles high, about 3,000 miles per hour. If we look at a little experiment here, we've got 2 sets of straws that have clay at the top of them. And I'll make this a little bit bigger. And I'll play that again. You can see that on the left here, we've got a little bit more mass and a little bit more weight, and it doesn't go that far. If we apply the same amount of pressure, you can see that the lighter straw goes a lot further. Same thing is happening in outer space. When we're dropping that extra weight that we don't need anymore, those solid rocket boosters are empty at that point. They're not carrying any more fuel. They've taken the space shuttle to where it needs to be. Those solid rocket boosters are empty, and they're just going to float back down to Earth. We don't want to be carrying dead weight, right? The less weight you have, the further that the shuttle is going to be able to go. So after we've released our solid rocket boosters, the shuttle is actually going to let go of its liquid fuel tank, or that external fuel tank. That was that big orange part 2 after about 8 minutes after liftoff, right? The tank is going to be mostly empty, but unfortunately the tank doesn't make it down to the ocean. It's actually just going to burn up in the Earth's atmosphere, and that can't be recovered, right? Awesome. So at this point, we're almost going 17,500 miles per hour, but we need that extra boost, right? And that's where the shuttle's orbital maneuvering systems come in, or the OMS. And if you come and visit the Space Shuttle Enterprise at the Intrepid Museum, you won't be able to see the space shuttle's main engines or its OMS because it's actually covered by a tail cone. But here you can see that that's what's going to give the shuttle that extra boost to get it that 17,500 miles per hour. Now, this is what the astronauts are going to use to steer and slow down enough for re-entry when coming back down to Earth. But the fuel in here acts a little bit differently. In here, you can find hypergolic fuel. Now, our fuel is made of monomethylhydrazine. And if you want to try and say that with me, you definitely can, but it is hard. And our oxidant is dinitrogen tetroxide. So thinking back when we were talking about our fire, right? Thinking about our candle, can anybody tell me what's missing from this equation? Let me know in the chat if you know what is missing. We have our fuel and our oxidant, but there was one more component to give us our fire. So I see some of us are saying the ignition. What's really cool about a hypergolic reaction is that you don't need an ignition to get that fire. When these two chemicals are in contact with each other, it looks something like this. Now, if you've ever taken a chemistry class, this probably looks terrifying, right? Or it could just look like a bunch of numbers and letters to you, but it actually looks like this. Like I said, when these two chemicals come into contact, they actually spontaneously combust. They don't need that ignition, right? In outer space, we want to keep things as simple as possible. We don't want any unnecessary fires or ignition going on when we can have these two chemicals here spontaneously combust when they touch each other or when they're combined, right? So you can also find this in the reaction control systems here, which if you come and visit us at the Intrepid Museum and you check out the Space Shuttle Enterprise, you can see that that fuel is located in those little gray spots, or the RCS there. Now, this is what helps on re-entry, right? To help the shuttle do movements like pitch, going up and down, yaw, going side to side, and even its roll motions as well. But when these shuttles are coming back down from outer space, these wings and that tail are basically useless, right? If we know anything about airplanes, the wings are used to manipulate air to help airplanes roll and yaw and pitch, right? But in outer space, these wings are completely useless until the shuttle enters the atmosphere. The shuttle can actually glide like an airplane. And like I said in the beginning, when we tested Enterprise, it was proven that these shuttles can actually land on a runway just like an airplane, right? And we can't really go into the future without studying the past. And a lot of principles used in our shuttle program are actually going to be used on our Artemis missions as well, which we'll get to in just a little bit. So now is a good place for a question break if anybody has any questions. Why is the external fuel tank orange? Yeah, it looks a little funky, right? But what it actually is, it's basically polyurethane, and it's used to insulate the chemicals that are inside, right? I mentioned that we have liquid hydrogen in the inside of that tank, and that foam keeps it at about negative 423 degrees. There's also liquid oxygen in there as well, and it keeps it at negative 297 degrees. Now, if you've ever seen maybe the first couple of launches, right, that liquid fuel tank, or the external fuel tank, wasn't orange. It was actually white. And it was because they painted it white to kind of keep everything looking consistent. But all of that extra paint to paint it white weighed it down by about 600 pounds. So by losing all of that paint, lost about 600 pounds, and pounds make a big difference when we're trying to launch the shuttle stack into outer space. Good question. Any more? Why does the shuttle leave the atmosphere belly up? So have you ever seen a shuttle launch, right? The shuttle kind of turns upside down and it leaves the atmosphere. After about a minute after liftoff, the atmospheric forces on the vehicle reach their peaks, right? So rotating the shuttle to make sure that it's facing downward right after launch puts the vehicle in a position that helps reduce stress on the wings and the tail of the shuttle. Good question. So looking at the inside of our shuttle pavilion here, if you were really disappointed to hear that the Space Shuttle Enterprise never went into outer space, we do have a Soyuz capsule at the museum. Right? And so this is how astronauts today ride up into outer space. It can hold about 3 astronauts. If you look closely here, you can see that they're very comfortable. Every seat is formed to fit them to make sure that they are very comfortable. Now, I did mention that NASA is working on the Artemis missions, right? And during the Artemis missions, right, these the main engines, right, are 4 RS-25s. They're going to be fed the same fuel that was in these shuttles. These rockets are going to be taking up the Orion, and reaching speeds at about 24,500 miles per hour, right? And we are going back to the moon, essentially, right? With Artemis 1, it's going to be an unmanned mission. It's going to head about 40,000 miles beyond the moon on its 3-week mission. But again, this isn't just taking up like the astronauts, but it's also taking up the Orion spacecraft and cargo going to the moon as well. Now, I did mention Artemis 1 is going to be unmanned. Artemis 2 is going to send up 4 astronauts to the moon before sending up Artemis 3, which will land astronauts on the moon, hopefully in 2024. A gateway will also be going, which is basically an outpost that's going to be hanging around the moon. Now, at 322 feet long, it's just under the size of the Saturn V rocket. So they're packing in a lot of power in a small amount of area, right? So you're probably wondering, why are we going to the moon if NASA's already been there? What's so great about going back to the moon? And I've also heard we're going to Mars, right? So going to the moon is considered deep space. And the Artemis missions will provide the solid understanding of deep space exploration. Now, everything that we learned, that NASA learned from the early missions, are going to help them learn how they're going to get to Mars. Just like the early astronauts were learning about the basics on getting up, coming back down, orbiting, eventually getting to the moon, NASA has to take these same baby steps when it's time to get to Mars as well. We've talked a little bit about the power and how much it takes to get somewhere. Can you imagine what it takes to get all the way to Mars? What does that even look like? Now, because NASA is going to be venturing a little bit further, they're going to need a lot more fuel. Again, more fuel adds more weight. The more fuel you're going to need. Plus, they have to remember to get back to Earth as well and bring everything that they need to help get to Earth. Now, the most efficient way to save fuel when going to Mars is making sure that Earth and Mars are at specific points in their orbit or particular locations, right? And when launched, the whole shuttle is going to have to actually jump and transfer orbits. Now, this placement doesn't happen very often, so it's got to be timed just right. So thinking about the future of space exploration, we really can't delve into the future until we have a solid understanding of our past and being able to take these little baby steps to get to where we want to be or where NASA really wants to be, right? NASA is still learning and applying these principles that they've learned from some of the earliest space missions. So thank you for joining me today on another Intrepid Adventures. The museum has introduced a number of live programming, so if you'd like to check any more of those out, you can find those on our website at intrepidmuseum.org, or you can subscribe to the channel or follow us on Facebook. Our next program is going to be this Thursday, June 10th at 3 p.m. It's going to be called Code Breakers, where you can learn a little bit about coded forms of naval communications and how they were used on board Intrepid. Come test out your decoding skills and create your own secret messages as well. Now, the museum is open to the public Thursday through Sundays from 10 a.m. to 5, and starting June 21st, we will be open 7 days a week. So definitely come by and check out our replica of the Mercury space capsule, Space Shuttle Enterprise, the Soyuz capsule, as well as a lot of awesome aircraft we have on board as well. Now, if you enjoyed this program, we invite you to answer a quick survey located in the chat. Now, once again, my name is Kara, and thank you for joining me on another Intrepid Adventure. See you next time.